press the bell icon on the YouTube app and never miss another update.
Hello students, we continue the next problem in exercise 1.3. Up to 7th main we finish up, 8th main. What universal set would you propose for each of the following? First one is the set of right triangles. Second one is the set of isosceles triangles. So what he asks, we have to write the universal set for these sets. Universal set means it is a big set, contains the number of subsets. If I write universal set, these two are, so this set I call it as A and this set I call it as B. These two are belongs in U. Yes, na? These two are belongs in U means in universal set, right angle triangles are also present as well as isosceles triangles are also present. So what we write? So better we write a universal set means the set of triangles. The set of what? Triangles. The set of triangles means the triangles contains right angle triangles, isosceles triangle, equilateral triangles, etc. Means universal set is nothing but the set of what? Triangles. One more questions. Next question. Ninth question. Given the sets A is equal to 1, 3, 5, B is equal to 2, 4, 6 and C is equal to 0, 2, 4, 6, 8. What he has, which of the, observe carefully, which of the following may be considered as universal set? Which of the following may be considered as universal set for all three sets? Means all these sets is a subset of universal set. For that he has given 4 sets. 4 options are given. We have to choose which one is universal set. So 4 options. The first option is 0, 1, 2, 3, 4, 5, 6. First option. Second one is empty set. Third one is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fourth one is 1, 2, 3, 4, 5, 6, 7, 8. So what we do here? We choose which one is universal set with respect to these 3 sets. Which one is universal set with respect to these three sets. If I take first option, 1 is present, 3 is present, 5 is present, 2 is present, 4 is present, 6 is present. Means AB is a subset of this set, no doubt. 0, S, 2, S, 2, S, 4, S, 6, S, 8. Observe here. Very important. 8 is present in C. 8 belongs to C, but 8 does not belongs to first option. That's why we cannot consider this as a universal set. And no doubt, empty is also not a universal set, because empty means it does not contains any elements. Yes, na? So next we will see this one also. For 1 is present, 3 is present, 5 is present, 2 is present, 4 is present, 6 is present. Good. 0 is present, 2 is present, 4 is present, 6 is present, 8 is present. Yes. For these three sets, this one we consider as a universal set. Third option is considered as a universal set. We will see the fourth option also. So 1 is present, 3 is present, 5 is present, 2 is present, 4 is present, 6 is present. 0, observe here, observe. 0 belongs to C, but 0 does not belongs to fourth set. 0 does not belongs to fourth set. So this one we cannot consider as a universal set. So the option is third one, because A, B, C. Why we choose third one? Since A, comma, B and C is a subset of third option. Is a subset of third option. Understand? That's why this third set we consider as a universal set. This completes the exercise 1.3. We will see the next concept in this chapter. Venn diagram. Venn diagram means what, sir? It is a diagram. What it indicates, what it represents. See, most of the relationships, between the sets are represented by a means of diagram called Venn diagram. By a means of diagram, most of the relationships between the sets are represented by a means of diagram called Venn diagram. It means what, sir? Observe here. What I do, I draw a rectangle. I explain with an example. Then only you are understanding. Rectangle. So, set of all real numbers are present in the rectangular box. In this rectangular box, nothing but the set of all real numbers. Means the rectangular box contains set of real numbers. Okay, na? So no doubt, in last classes we explained natural number is a subset of integer. Integer is a subset of rational number. Rational number is a subset of real numbers. Means all these numbers, natural number, integer, rational numbers are a subset of what? Real numbers. And even though irrational numbers is also a subset of what? Real numbers. What I do, here I write natural numbers. 1, 2, 3, like that. 5, 6. This I enclosed in a closed curve. This I enclosed in a what? Closed curve. The curve may be circle. Closed curve means usually what? It is a circle. Then here I write integers. Here I write integers. So integers contain what? Natural numbers along with the natural numbers. Integers contain what? Natural numbers. Along with the natural numbers, 0, negative numbers, -1, -2, -3, like that. Integers. Correct na? Integers. So one more I write rational numbers. Rational numbers means it includes what? Natural numbers, integers, and a numbers in the form of p by q. Correct na? A numbers in the form of p by q. Yes. And here one more closed curve, circle. Here it is irrational numbers, √3, √5, pi, etc. √3, √5, pi, etc. Observe this diagram carefully. This diagram I call it as Venn diagram. This diagram I call it as what? Venn diagram. See, Venn diagram means most of the relationship between the sets. These are all relationship. What is the relationship? Natural number is a subset of integer. Integer is a subset of rational numbers. Rational number is a subset of real numbers, means natural number, integer, rational number is a subset of real number. This is the relation, subset relation. And even though irrational number is a subset of real number. So all the relationship I represented by means of diagram. I represented by a means of diagram. This diagram we call it as what? Venn diagram. Understand? So Venn diagram means it is a diagram in which the relationship what we expressed in the set, between the sets, we represented in a diagram. We represented in a diagram. So here one very important point. This R we call it as what? Universal set. Yes, na? This R we call it as what? Universal set. Observe here, I represent universal set in a rectangular box. Yes, that means always in Venn diagram, universal sets are represented by a rectangle. Very important concept. Right here, first one. Universal. It is very important. Universal sets are represented by a rectangle. Understand? So always in a Venn diagram, very important, always in a Venn diagram, universal sets are represented by a rectangle. And natural number, integer, rational number, irrational numbers are represented by a closed curve. Are represented by a closed curve means second one, subsets are represented by a closed curve. Or closed curve means circles. Closed curve means circles. See, observe here. So natural number, closed curve, integer, closed curve, rational number, closed curve, irrational number, closed curve. It may be circles. Okay, now. So universal sets, very important. In a Venn diagram, universal sets are represented by a rectangle. Universal sets are represented by a rectangle. And subsets are represented by a circle. See, one circle, 2, 3, 4. This diagram we call it as what? Venn diagram. Understand? John Venn is one of our mathematician. That's why he find the Venn diagram. That's why we name it as Venn diagram. So Venn diagram means, once again I say that Venn diagram means most of the relationship between the sets are represented by a diagram. So in the Venn diagram, universal sets are represented by a rectangle. Universal sets are represented by a rectangle, and the subsets are represented by a circle. Subsets are represented by a circle. Clear? So better we take one more example. One more simple example. So what I do, natural numbers. 1, 2, 3, 4, 5, 6, 7, 8, like this. This is nothing but a universal set. So my universal set. So universal set are represented by a rectangle. Natural numbers. All this. Subsets we write. I write here A set. A contains 1, 2, 3, 4. B contains 3, 4, 5, 6. C contains 7, 8, 9, 10. No doubt A, B, C. Observe here. A, B, C are all subset of what? Here. We represent by circles. This is the set A set. It contains 1, 2, 3, 4, yes now, and B set because 3, 4 is common in both A and B. That's why this is common in both A and B. 5, 6, C set, 7, 8, 9, 10. Observe here. This diagram we call it as what? Venn diagram. Once again I explain. In a Venn diagram, universal sets are represented by a rectangle. Very important. Universal sets are represented by a rectangle, and subsets are represented by a closed curve. Closed curve means circle. Closed curve means circle. This type of diagram we call it as what? Venn diagram. Clear? Okay, we will see the next concept. Next concept, operations on sets. Very, very important. Operations on sets. Under that, first one, operations on sets. Union of sets. Union of sets. Operations on sets. First operation is union of sets. So I explain by using an example. Okay, then it is very easy to understand. So we take two sets. A contains A, B, C. Set A contains A, B, C. B contains C, D, E. C, D, E. Union of two sets. Union of two sets. First point. Observe very carefully. Union. Union of two sets. Union of two sets denoted by A, then write capital U, then write B. This is very important. First one. Union of two sets. Union of two sets denoted by A union B. U means capital U. A union B. So next, A union B is also a set. See, observe, union of sets. A union B is also a set. It contains which elements? The elements present in A as well as present in B. It contains the elements which are present in A. The elements which are present in A. What are those elements? A, B, C. Union, once again I say that it is very important. Union of two set is also a set. It contains the elements which are present in A. What are those elements? A, B, C. As well as the elements which are present in B. The elements which are present in what? C, D, E. So, you already write C. So, we know that repetition of the element is not allowed. Okay, C is also present. Next, D, next E. This is what? The union of two sets. Understand? Union of two sets. So, union of two set is also a set. It contains the elements which are present in A. It contains the elements which are present in A as well as the elements which are present in B. It is very important. If you want, I take one more example. Very important. So, I take one more example. Then we write the definition. Example 2. What I do, A is equal to 0, minus 1, 3, 4. Okay, now 0, minus 1, 3, 4. B is equal to 3, 4, minus 2, minus 5. Enough, sir. That is 3, 4, minus 2, minus 5. So, you know that A union B is denoted by A capital U B. This is the notation to denote union of two sets. A union B. Then, A union B is also a set. A union B is also a set which contains the elements which are present in A. What are those elements? 0, minus 1, 3, 4. As well as the elements which are present in B. What are those elements? 3. We already write. No need to write once again because repetition of the digit is not allowed in the set. So 3 is over. 4, yes, already we write. Then, what are those remaining elements? Minus 2, minus 5. This is what the union of two sets. Understand? Very important concept. This is what? The union of two sets. Now, I write the definition. So, you already know the concept. Very important concept. Okay. Let A and B are two sets. A and B are two sets. Okay. The union of two sets. The union of two sets is denoted by A union. I write below. The union of two sets is denoted by, okay, right here, A union B and defined A union B is equal to, I write in the set builder form, okay, A union B is equal to X such that, A union B is equal to X such that X belongs to A or X belongs to B, X belongs to A or X belongs to B, or I read below, X belongs to both A and B. X belongs to A, understand, or X belongs to B, or both X belongs to A and B. This is what the definition of what? A union B. Understand? A union B. So once again I say that operation on a sets, first one is union of two sets or union of three sets. Firstly we take only two sets. Union of two sets is denoted by A capital U B. Okay, we can read as A union B. So A union B means it is also a set. It is also a set. So the elements which are present in A as well as the elements which are present in B. So 0, -1, 3, 3 is repeated, 4 is repeated, no need to write 2 times, we write only 1 times, -2, -5. So that I write in the set builder form. X such that X belongs to A or X belongs to B means present in A or present in B or both present in A and B or both present in A and B. This is what the definition of union of two sets. Understand? So we solve some problems regarding union of two sets. Okay, take down problems. So exercise 1.4. Exercise 1.4, first main problems. Find the union of each of the following pairs of sets. First problem. X is equal to 1, 3, 5. Y is equal to 1, 2, 3. X is equal to 1, 3, 5. Y is equal to what? 1, 2, 3. Then X union Y. You also write. You know the concept already. 1, 3, 5. 3 is repeated. 1 is repeated. Only one left is 2. X union Y. Second problem. A is equal to A, E, I, O, U. B is equal to A, B, C. Then write the answer also, okay? A union B. Very done. A, E, I, O, U. A is repeated, only 2 elements are there, B, C. Correct na? B, C. Third problem. A is equal to x such that x is a natural number, and multiple of 3. A is equal to x such that x is a natural number and multiple of 3. B is equal to x such that x is a natural number and x greater than 6 less than 10. X greater than 6 less than 10. Okay. So these two are given in what? Set builder form. So we write in roster form first. Natural number multiple of 3 means 3, 6, 9, 12, 15 like that. A set. B set. Natural number in between 6 and 10. 7, 8, 9. 7, 8, 9 because greater than 6, less than 10. Then we write the answer A union B. 3, 6, 7 is also there, 8 is also there, 9, 12, 15 like that. It never ends. It is an infinite set because the A set is an uncountable element. That's why it is an infinite set. So 3, 6, I write 7, 8 is also 9, 12, 15 like that. Understand? Next problem. Next problem, fourth problem. What is given? A is equal to x such that x is a natural number and x greater than 1 less than or equal to 6. B is equal to x such that x is a natural number and x greater than 6 less than 10. Greater than 6 less than 10. Then A we write in roster form. So he has given in set builder form. So 2, 3, 4, 5, 6. 1 is excluded, 6 is included. B is equal to what? 7, 8, 9. Correct? So A union B. 7, 8, 9. A union B is equal to 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. Next question, fifth question. A is equal to x such that x is a natural number and multiple of 3. B is equal to x such that x is a natural number less than 6. So just now we discussed this problem. A is equal to 3, 6, 9, 12, 15 like that. B is equal to natural number less than 6. 1, 2, 3, 4, 5, less than 6. Then A union B, A union B, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The next 6, 9, 12, 15, etc. 18, correct na? 18, 21, 27, 30, multiples of 3. Multiples of 3. Next question. Sixth one. A is equal to 1, 2, 3. B is equal to empty. Very interesting. Very interesting problem. A union B is nothing but 1, 2, 3. That is equal to A itself. Because B contains no elements. That's why A union B is equal to 1, 2, 3. That is A itself. First main is over. Second main. Second main, he has given, let A is equal to A comma B, B is equal to A, B, C, is a subset of B question mark. Next, find A union B. Find A union B. So A is equal to A comma B, B is equal to A, B, C. Observe here, all elements present in A are also present in B. First one. Hence, one sentence we write, all elements present in A are also present in B. All elements present in A are also present in B. That implies A subset of B. A union B. A union B is nothing but A, B, C. So A union B is nothing but what? B. Very important. What is A union B? A union B is nothing but what? A union B is nothing but what? B side. Second question is over. Third question. Third question. If A and B are two sets such that A subset of B, then what is A union B? What is A union B? In the previous problem, just now we discussed, just now, since A subset of B, that implies A union B is equal to what? B. Just now we discussed in the previous problem. A subset of B, that implies A union B is equal to what? B. Next question. Fourth one. If I write above because it is a very lengthy problem. Fourth question. If A is equal to 1, 2, 3, 4. B is equal to 3, 4, 5, 6. C is equal to 5, 6, 7, 8. And right here only, and D is equal to 7, 8, 9, 10. 7, 8, 9, 10. 4 sets are given. So what he asked, find one by one. Find first one, A union B. Write the answer only. A union B. A union B. 1, 2, 3, 4, 5, 6. Second one, A union C. A union C. This one. 1, 2, 3, 4, 5, 6, 7, 8. You also write. Third one, A union C over. Third one, B union C. B union C. So B union C, these two sets. Write it. 3, 4, 5, 6, 7, 8. Fourth question. 3, 4, 5, 6, 7, 8. Fourth one. B union D. B union D. B union D. These two. 3, 4, 5, 6, 7, 8, 9, 10. Correct? 7, 8, 9, 10. Fifth question, A union B union C. These three, A union B union C. We combine three sets. A union B union C. The element which are present in A as well as B as well as C. Okay. A elements are there. 1, 2, 3, 4. B elements 3, 4, 5, 6. 3, 4 already we write. 5, 6. C elements 5, 6, 7, 8. 5, 6 we already write. 7, 8. So A union B union C is 1, 2, 3, 4, 5, 6, 7, 7, 8. Understand? Next one. A union B union D are right here. I think problem number 6th one. A union B union D is equal to, right below, A union B union D. So A union B union D. Combining these three sets. Write first A set. 1, 2, 3, 4. B set. 3, 4, 5, 6. 3, 4. 5, 6. D set. 7, 8, 9, 10. Correct now? 7, 8, 9, 10. So the last question. The last question is, the last question, I think 7th one. B union C union D. B union C union D. B union C union D. These three sets. B union C union D. Okay. So first we write B set 3, 4, 5, 6. C set 5, 6 already over. 7, 8. D set 7, 8 already over. 9, 10. B union C union D. So understand the concept. A union B, it is very important. First operations on a set. A union B. Okay. Next. Next concept. Second operations, intersection of sets. Very important. Union is over. Second operation, what? Intersections of two sets. We explain by using an example. Okay, we write example A set first. Let A is equal to, it contains some elements A, B, C, D. B is equal to, it contains A, C, E, F. Okay, A, C, E, F. Then, first concept, the intersection, very important, intersection of two sets is denoted by A intersection B. Ulta U. If I write like this, it is union. If you write ulta, A intersection B. A intersection B. This is very important. Intersection of two sets is denoted by A intersection B. It is also a set. What we discuss in union, A intersection B. A intersection B is also a set. It contains common elements present in A and B. It contains, once again I say that, A intersection B is also a set which contains, very important, which contains common elements present in A and B. Very important. Which contains, observe carefully, which contains common elements present in A and B. Observe A and B, common elements, what are those? A is present here, A is also present here, A element. B present in A, but B is not present in B. Okay, C present in A, C is also present in B. Common element. These two are common elements. This is what the concept of intersection of two sets. Intersection of two sets is also a set. Very important. Intersection of two sets is also a set which contains what? Common elements. Here in A and B, common elements are A and C. A and C. Okay, so we take one more example. Example 2. Let A is equal to 1, 2, 3, 4. B is equal to 3, 4, 5, 6. Then A intersection B is what? Already you know, A intersection B is what? Common elements. 1 is present in both A and B? No. 2 is present in both A and B? No. 3 is present. 4 is also present in both A and B. So the A intersection B is what? A intersection B is what? 3, 4. Okay. Next. So we write the definition. Let A and B are two sets, the intersection of A and B is denoted by and defined as A intersection B is equal, write in the set builder form, X such that X belongs to A and, very important, X belongs to B. Observe here, X belongs to A, the elements X, it is belongs to A as well as and belongs to B. This is what the definition of what? Intersection of two sets. Clear? Intersection of two sets. X such that X belongs to A and X belongs to B. This is what the concept of intersection of two sets. We solve some problems regarding intersection of two sets. In first one, find the intersection of each of the following pairs of sets. First question, X is equal to 1, 3, 5. Y is equal to 1, 2, 3. So X intersection Y, common element present in both the sets. 1 is present, 3 is present. Understand? 1 comma 3. Second domain, A is equal to A, E, I, O, U. B is equal to A, B, C. A, B, C. So A intersection B. A intersection B is what? Only one element, that is A, present in both the sides. Yes? Third question. A is equal to 1, 2, 3. B is equal to empty. B is equal to what? Empty. Then A intersection B is also empty because we write the common elements. Since B is an empty, A intersection B is also empty. Why it is empty? There is no common elements. That's why A intersection B is also empty. Fourth question. A is equal to X such that X is a natural number and X greater than 1, less than or equal to 6. B is equal to X such that X is a natural number and X greater than 6, less than 10. X greater than 6, less than 10. So these two sets are given in rule method. So we write in tabular. So 1 to 6 we have to write. 1 is excluded, 6 is included. So 2, 3, 4, 5, 6. B is equal to 6 and 10 are excluded. 7, correct na? 8, 9. What about A intersection B? No common elements. Correct na? No common elements are present. That's why A intersection B is an empty set. A intersection B is an empty set. One more question. Fifth one. A is equal to x such that x is a natural number, x is a natural number and multiple of 3, b is equal to x such that x is a natural number and x is a natural number less than 6, x such that x is a natural number less than 6. We write in tabular form. A is equal to 3, 6, 9, 12, 15. Okay. B is equal to 1, 2, 3, 4, 5 less than 6. Then A intersection B, common elements. 1 is present, no. 2 is present, no. 3, only one element. That is what? 3. A intersection B is equal to 3. Understand? So, okay. So, this is very important. Once again, I explain intersection of two set. It is nothing but a common elements which are present in A and B. Okay, we stop up to this. We continue the intersection of two set problems in next class. Thank you.